Imagine looking up at the night sky and seeing something you've never seen before. The familiar constellations are there, Orion with his bright reddish shoulder star. Betelgeuse. But tonight, Betelgeuse is gone. In its place, a blinding new light. NASA has just released footage. Betelgeuse, one of the brightest stars in our sky, has exploded. This isn't science fiction, it's cosmic reality, captured in stunning detail. The universe just put on the greatest show in history, and we all had front row seats. The news spread instantly, across the globe, through every screen and speaker. Everyone asked, what happened to Betelgeuse? Astronomers always knew this day would come. Betelgeuse was a ticking time bomb, but seeing it happen is something else entirely. NASA's images are breathtaking. The star pulsates, shudders, then erupts in a blinding flash. A wave of energy and matter blasts outward into space. If NASA's telescopes hadn't been watching, this would sound like a myth. This is a star in our own cosmic neighborhood, not some distant galaxy. Betelgeuse has been a celestial landmark for cultures worldwide. Its disappearance and the birth of a new light change our view of the heavens. The universe is not static, it's dynamic, violent, and beautiful. Stars are born, they live, and they die. Tonight, we witnessed one of the most magnificent deaths. This discovery is a testament to human curiosity and ingenuity. We build incredible machines, point them at the void, and sometimes the universe answers. Most of the time, we find subtle clues. This time, we caught the cosmos in the act. We saw creation and destruction on a scale hard to imagine. The Betelgeuse explosion is not just an astronomical event, it's a shared human experience. It connects us all to the grand unfolding drama of the cosmos, and it's a reminder the universe is always changing and so are we. Who was Betelgeuse? Before its grand finale, it was one of the most famous stars in the sky. Easily spotted in Orion, Betelgeuse marked the hunter's right shoulder, a massive red supergiant. If Betelgeuse replaced our sun, it would engulf Mercury, Venus, Earth, and Mars, maybe even Jupiter. It shone with the light of over 100,000 suns. But massive stars like Betelgeuse live fast and die young, burning through their fuel in just a few million years. Recently, astronomers noticed Betelgeuse dimming and brightening unpredictably, a sign that something big was happening inside. Its name comes from Arabic, and it's been part of human culture for over 1,000 years. Ancient stargazers across the world noted its unique color and brightness. Betelgeuse was a celestial marker, a guide, a character in countless myths. Its constant presence made it feel permanent, until now. Its dramatic end reminds us, nothing in the universe is truly permanent. Betelgeuse was only 650 light-years away, making it a perfect laboratory for studying massive stars. We could see its surface, measure its size, and track its strange pulsations. We always knew it would go supernova. Now theory has become reality. The final chapter of Betelgeuse is now written in the sky. So what exactly is a supernova? Imagine a star as a massive nuclear engine, fusing lighter elements into heavier ones in its core. For most of its life, a star like Betelgeuse fuses hydrogen into helium, balancing gravity with energy. But eventually, it runs out of hydrogen. Gravity wins, the core contracts, and new fusion stages begin: helium, carbon, oxygen, and so on. Each stage is shorter than the last until the core creates iron. Fusing iron doesn't release energy, it consumes it. The star's core collapses in an instant. The outer layers slam into the dense core, bounce off, and a titanic shockwave rips the star apart. That's the supernova, a colossal explosion outshining entire galaxies for weeks. It's not just a death, it's a transformation. The explosion hurls the building blocks of life across space. New stars, planets, and maybe even life will form from this cosmic debris. Supernovas are the universe's way of recycling matter, and now we've seen it happen up close. When the news broke, the world changed. Astronomers stared in disbelief. Betelgeuse was gone, replaced by a brilliant new light. Social media exploded. People everywhere rushed outside, phones in hand, to see history unfold. For the first time in modern memory, the night sky offered a spectacle no one could ignore. The new star was so bright, it was visible even from city centers, casting faint shadows at night. Scientists coordinated observations from every telescope on Earth and in space. For the public, it was something deeper, a connection to the cosmos. Families gathered, friends met in parks, teachers took students outside. It sparked millions of conversations about our place in the universe. It was a unifying event, science and wonder side by side. Of course, there was confusion and fear. Were we in danger? Scientists reassured everyone. Betelgeuse is 650 light-years away. The danger is long past. The light we see is an ancient echo. Fear turned to fascination. The supernova became the greatest science lesson in history, delivered across the night sky. For a moment, humanity looked up together. We were reminded how small we are and how connected. The universe had everyone's attention. For astronomers, witnessing a supernova in our own galaxy is the holy grail. The last one visible to the naked eye was over 400 years ago, before the telescope. We see supernovas in distant galaxies all the time, but up close it's a different story. With Betelgeuse we can study every detail, the expanding cloud, the light, even elusive neutrinos. It's the difference between reading a summary and having the whole library. Now we have real data, direct observations that will rewrite textbooks. The supernova early warning system, SNOOZE, was ready. Neutrino detectors gave us a heads up before the explosion's light arrived. Every telescope turned to watch, ensuring not a moment was missed. This event will fuel scientific research for generations. Betelgeuse's supernova is a once-in-a-lifetime opportunity. How did NASA capture this spectacle in such detail? Preparation. NASA's fleet of observatories, on the ground and in space, was ready. The James Webb Space Telescope peered through dust, tracking the shockwave and analyzing new elements. Hubble captured the visual evolution, creating a time-lapse of the expanding debris. Chandra X-ray Observatory mapped the hottest regions, revealing the explosion's temperature. Ground-based telescopes listened for radio waves from the blast. By combining all this data, scientists built a complete 3D picture of the event. Thousands of people worldwide collaborated, engineers, scientists, and more. Capturing Betelgeuse's supernova was the ultimate test of our astronomical capabilities. The result? One of the most comprehensive datasets in science. Betelgeuse's legacy will live on, not just in our sky, but in our understanding of the universe. Humanity was ready, and we didn't miss a thing. Betelgeuse's explosion is more than a light show. It's a cosmic experiment. One key question: how are heavy elements like gold and platinum created? Supernova nucleosynthesis, the forging of new elements in the explosion, can now be studied directly. Using spectrographs, scientists can read the barcodes of elements in the supernova's light. We can finally confirm if the universe's greatest treasures are made in these violent events. The data also helps refine our models of how supernovas actually explode. For years, computer simulations struggled to match reality. Now, we have the missing ingredient: real data. Scientists can tweak their models, deepening our understanding of gravity, neutrinos, and fluid dynamics. The expanding nebula will mix with interstellar gas, seeding new stars and planets. The death of Betelgeuse is the beginning of new creation. We're watching the cycle of cosmic life unfold. The universe is its own laboratory, and we're finally able to observe the experiment. The Betelgeuse supernova isn't just about a distant star, it's about us. Every atom in your body, except hydrogen and helium, was forged in a star's heart and scattered by a supernova. We are, quite literally, made of stardust. Seeing Betelgeuse explode makes this connection real. That cloud of debris will one day become new stars, new planets, maybe even new life. Our own solar system formed from the remnants of ancient supernovas. The gold in a ring, the iron in your blood, all born in stellar furnaces. The universe is not just out there, it's in us. The death of a star 650 light-years away is part of our own origin story. We are the cosmos, looking back at itself. The explosion of Betelgeuse marks a new era in astronomy, and in our relationship with the cosmos. For centuries we pieced together the universe from faint clues. Now, we've seen its power firsthand. The data will fuel discoveries for decades, deepening our understanding of the cosmos. The Betelgeuse supernova shatters the illusion of an unchanging sky. The universe is alive, evolving, and being reborn. This event inspires a new generation of scientists and explorers. Children who looked up in awe will build the next telescopes and unlock new secrets. The story of Betelgeuse connects us to the past, to each other, and to the future. We were the generation that witnessed it. We looked up, and the universe looked back. The journey is just beginning. There are more stars, more mysteries, and more stories waiting to be discovered. The cosmos is calling, and we are ready to answer.